So today we're going to look at the area of sectors and sectors in composite figures. So here we need to be able to identify the formula used for the area of semicircles, quadrants and sectors, calculate those areas, and also apply the formula of the area of a circle to solve these problems if they're involved in composite shapes. So to start off with, the key things we need to consider is, well, what is a sector? A sector is formed by dividing a circle with two radii. So notice what I'm essentially looking at is a slice of the circle or a part of the circle. So here, if you ever see something that is incomplete or a circle that is incomplete, I want you to think about it here as a sector, or here if I've taken a slice. Now, if I want to find the area of this sector, what I could do is that notice that if I were to travel all the way around, so if I were to complete, let's just say here, I've got my circle. If I were to go all the way around back to the start, notice that that would be an angle of revolution, which is 360 degrees. So here, if I only have a portion, now this little symbol here, if we don't know what that is, this little symbol here is a Greek symbol and it's called theta. And theta just represents some angle. So here, what I'm looking for is that I'm taking that angle and I'm putting it over 360 degrees. So my first step that I'm going to do to solve these problems is determine the fraction of the sector, or the fraction of the circle, I should say. And the second step is to find the area by multiplying that fraction by the formula for the area of a circle. The second part of the lesson, we're going to look at a composite shape. Recall that a composite shape is made up of two or more different shapes. So here we can do different sort of methods. So for example, with something like this, I could split up my working out and find the area of those two shapes separately and then bring them together. So you'll notice that the first one is a rectangle, so length times breadth. And the second one is, can you see it is a semicircle? So it is half of a circle. So 1/2 times pi r squared. So let's look at our first three examples. So if I'm looking at the area of a semicircle, there are two ways to think about it. A semicircle, notice that a straight line is 180 degrees. So here I can write my fraction as 180 over 360, or that can be simplified as a half. So find the fraction, and then your second step is to find the area, which is the fraction multiplied. Now recall here, the area of a circle is pi r squared. So here I'm going to do times pi times the radius, which is 6, all squared. So here, what we might do is, for this example here, we might leave our answers to 1 decimal place. So here, actually, what I might do before I leave it to 1 decimal place, recall here that in some of our calculators, they leave it in this form here. Remember that this is called exact value. Now, if I want it to 2 decimal places, I need to use my calculator buttons, and then I will get 56 point, let's say 5. And I'm just going to put to 1 decimal place. We're going to try the same steps again for the area of a quadrant. So quadrant meaning 4. So my first step is the fraction. So I can write that as 90 degrees over 360, or if you've already recognized, it is 1/4. So then to find the area, I need to take 1/4 and multiply it by the area formula of a circle, which is up here. So it will be multiplied by pi multiplied by 0.28 squared. And here I'm going to leave my answer for this one to 1 decimal place. So here it will be 0.1, I believe. What have we got? Meters. Oh, sorry, I forgot to put that in the last one. So meters squared, and the other one should be centimeters squared. So now we're going to look, well here, notice that I don't have a fraction that simplifies or is as obvious as 1/2 or 1/4. So here I can still apply the same rules and it's still going to give me the correct answer. So I'm going to start by writing the fraction. So here I'm going to take the angle within the sector, which is 135, out of 360. So think I've taken 135 degrees out of a total of 360. Now, if I wanted to, I can simplify that by putting the fraction in my calculator or using common factors to get 3/8. So here, I'm then going to take my fraction to find the area and multiply that by pi and multiply that by the radius squared. And here I'm going to answer to 2 decimal places for this one. So it will be 265.1, in this case, centimeters squared. Now what I want you to recall for this one, remember here that we take the angle within the sector and put that over 360. If you're wondering how I got 3/8, what I did is there are 2 ways. I can find a common factor of 135 and 360. And here 45 is a common factor, but that's quite a large number. So the other option is if I put this directly into my calculator, it will give me the simplified fraction like so. Now what I want you to do is on the next page, we have some examples. So take your time to pause the video, have a go at those examples, and then you can come back to check your answers. Otherwise, if you're still not feeling sure, then you can stay watching the video as I go through these examples. So for our first one, I'm going to find the area. So here, my fraction is 60 over 360. So to find the area, I'm going to put into my calculator 60 over 360 times pi times 6.5 squared. And in this case, now remember 2 significant figures, I have to count the first 2 non-zeros. So that's going to be 22. Now with B, notice that I have the diameter. For area, I must have the radius. So I need to halve 22. So here by halving 22, my radius is going to be 11. Notice here that the shaded part is a semicircle, which is a half. So I'm going to have 1/2 times pi times 11 squared. The next thing I'm going to do is for part C. Notice here, I don't have the exact degrees, but I do have my right angle symbol. So I know I have a quadrant, or otherwise a quarter of a circle. So the area will be 1/4 multiplied by pi multiplied by 8 squared. And that's exactly what I'll put into the calculator. When I get to D, now here, remember I need my fraction over 360. So to find my area, the first thing I'm going to put into my calculator is the fraction multiplied by pi multiplied by 15 squared, or the radius squared. With E now, what I want you to notice is, can you see that the shaded part is actually the large part? So here it's actually, I'm not looking at the quarter. To find the area of this shaded part here, can you see that the angle within the sector is going to be 270? So here, the area of this one is going to be 270 over 360 multiplied by pi multiplied by the radius of 10 squared. So to recap here, the reason why I did 270 over 360 instead of the 90 is because I'm looking for the area of the shaded sector, which is that part just here, which is 270 degrees. Similarly for F, I'm looking at the shaded part, so I'm looking at 225 degrees. So here my area will be 225 over 360 multiplied by pi multiplied by the radius of 12.8 squared. Now we're going to move into the area of composite shapes. So I'm going to combine my understanding of areas of sectors as well as the other formulas we've used to find the area of other different shapes. So here, the way I like to calculate these questions here is I like to label them. So I've got, for example, shape 1, shape 2. So I start by finding the area of shape 1. Now notice here that that is a semicircle. So the fraction of that semicircle is a half, and I multiply it by pi times the radius. Notice the radius is this part here. So the radius will be 2 squared. So here I will end up with 2 times pi. So let's go here. We'll do everything for these questions here. Let's go to 2 decimal places for this one here. And what I want you to do is when you're working through these questions, try to keep everything in exact form as much as possible. So if I put this in the calculator, I should be able to get 4 pi. Or if I'm getting a decimal, for those, I want you to think 4 squared divided by 2. Oh, sorry, it shouldn't be 4. Should be 2. So here, 4 squared divided by 2 needs to give us an answer of 2. Now I'm going to find the area of the second section, which is going to be a rectangle. So here, notice that I have this side here, 2. Now to find the length of this rectangle, can you see that it's also the diameter of the semicircle? So here, if the radius of the semicircle is 2, well, the diameter is twice the radius. So here, that would mean that this part is 2. So that means the whole entire length is going to be 4, and then 2 times 4 equals 8. So my total area, so the area of 1 and 2 is going to be 2 pi plus 8 centimeters squared. I'm now going to have a go, so for B. So here, notice that I have curved edges, but can you see I have 2 semicircles? But so if I actually bring these semicircles together, can you see that I actually have 1 whole circle? So here for the area of the first shape, I'm going to have an area of 1 whole circle, which will be pi. Now the radius of this here, now the whole diameter is 12, so that means the radius must be 6, so 6 squared. So I get 36 pi. My next shape is the rectangle here. Now, can you see that the length of the rectangle is 12, its width is 12 and its length is 20. So the area of the second shape will be 20 times 12, which should be 240. So my total area will be 36 pi plus 240 meters squared. So here with these particular composite shapes, I'm now asked to find the area of the shaded region. So here what I normally like to do for this one here is I find the area of the whole shape, and then my second step is to subtract the shape that isn't shaded in. So what you can see here is, can you see that in blue, my first shape is actually a rectangle. So here, actually let's make this 1. So I've got my rectangle, and then my second shape here is a semicircle. So here, for me to find the area of the shaded shape, notice that the area is going to be equal to 1, so the entire rectangle minus the part that's actually missing. So again, I'm taking this whole area here, and then I'm taking away the semicircle, so that way I'm only left with these shaded parts here. So, for example, for A, the area of a rectangle, so I've got the length, which is 20. Now, if I want to find the width here, well, the question is, well, how? Because I only have the length. Well, if we think about the properties of a circle, notice this dot is the center of the semicircle. So if I were to draw from the center of a circle to any part on the outer skirts of a circle, that there is the radius. And that means that this 20 centimeters is the diameter. Now, if I want to find the radius is half of the diameter. So that means the radius will be 10. So the radius is the width of my rectangle. So that is 200. Now my next part is to find the area of the semicircle. So our steps are find the fraction. So the fraction is a half. Multiply that by the area of the circle. So pi times the radius squared. So I get 50 pi. So now my area is 200, take away 50 pi centimeters squared. I'm going to do something similar here. So now in this instance, I actually have, they're the same shape, but of different sizes. So here, imagine that this large shape here, so this large circle, if I were to completely cover it in, so that's going to be my first circle. And then what I'm doing is I'm looking at, well, if I remove, let's maybe use this one here. If I can remove everything inside, well, then I would need to find the area of the second circle, which is the smaller circle. Well, so here what we might do is we'll put the large circle and I'll make this a small circle. So that's what we have to do there. So let's start with the large circle. So then my area, actually I'll write this up here, is the large circle minus the small circle. So the large circle, well, these are complete circles. So the area of a circle is pi. Now here, the radius of the large circle is the line that is subtending from the center to the outer skirt here. That's going to be times 11 squared. Sorry, I meant to write 121. And then if I go to find the area of the second circle, which is the smaller one, then its radius is 9. So it will be pi times 9 squared. So the area is equal to the large circle taking away the area of the small circle. Now, I know pi is a number, but we can think about this as like terms. So I can actually do 121 less 81. But what I'm going to do is I'm going to leave my pi in my final answer. And what's my units? Centimeters squared.